So here we have a circle. Looks like spinning that way. There are points Z, P, Q. This is R, and that's a mass M. So A, draw and label the force exerted on the ball when at the points P and Q. Points P and Q, and this at Q, there's this and this. This is FG, that's T, this is FG. Questions about the labels? Everybody okay with that? Alrighty. Then B. Oh, I'm writing everything in green. An expression for V minimum at point Z. Forces are T and FG. So the sum of the forces at point Z are equal to mv squared over r. How do I know this? Because it's moving in a circle. And anything in the universe that moves in a circle has the sum of the forces mv squared over r. It is not possible to move in a circle without this result. So then, this is going to be T plus Fg equals mv squared over r. Now, it says minimum vertical velocity. Minimum. What happens at the minimum vertical velocity to the tension in the string? Yeah, it's the least. If I take this yo-yo and I spin it like this, as I slow down the spin, do you see what's happening? Yeah, it's no longer moving in a circle. And if I just keep it so that it's moving in a circle, but barely, then as Jordan said, you can see there's like slack in the string. How much tension is there in a string that is slack? Yeah, it is. The tension is 0. And as Monica's intimating, okay, if the tension's 0, then who's making that move in a circle? Gravity. So tension goes away at minimum velocity. And so we get mg equals mv squared over r, masses cancel. We get v is the square root of rg. That in general is called minimum vertical velocity. All right, so we move on to part C. Part C says the maximum tension the string can have without breaking is Tmax. Derive an expression for Vmax, the maximum speed the ball can have at point Q without breaking the string. So, same idea, right? Point Q, diagram, point Q, right? T and F are now in opposite, or T and FG are in opposite positions. So once again, I say it has to be mv squared over r. Now, which way does mv squared over r point? Jennifer. Which way does the centripetal force point? Very good. In towards the center. Centripetal, meaning center seeking. So that means towards the center is positive. So I say T minus Fg equals mv squared over r. Questions? Have I lost anybody? Do you see why they have one? You see why Fg has to be opposite? Because it's pointing opposite of T. So then, here I can solve, now just solve this, well, okay, I can make this m or whatever, but solve this for v, that's it. So v is going to equal r over m, the square root of r over m times t minus mg. And that's, of course, assuming that this is Tmax. Then D, suppose the string breaks. Describe the motion of the ball immediately afterwards. Understand circular motion. Point P is going to be A. This is going to be B. This is going to be C. And this is going to be. If the string breaks right here at point P, which way does the ball move? A, B, C, or D? Turn this on. So that's pretty much it. The answer there is straight up. You draw that in, and I think you just have to explain that, like an object in motion. I mean, you can just say because of Newton's first law, an object, that this ball at point P wants to keep going in its direction, which is straight up. So unless the string is there to pull it, it's going to go straight.